All right, let's talk about the single most frustrating part of machine learning, dealing with messy, chaotic data. What if I told you there's a way to build a cleaning machine, a perfect, repeatable recipe that gets it right every single time? Well, stick around because we're about to build exactly that using scikit-learn.
I mean, if you've ever tried to build a model with real data, you know this feeling, right? You get a new data set, you're all excited, but first you have to spend days, sometimes weeks, just wading through a swamp of data cleaning. It's like the biggest part of the job.
And yeah, you're not wrong about that feeling. But that's the big idea for today. We're going to build an automated, error-proof workflow. Just imagine a system where you feed in raw, messy data on one end, and it gets transformed perfectly on the other, ready for your model, automatically. That's the goal.
Okay, so to really appreciate how cool the solution is, we gotta get our hands dirty with the problem first. Let's dive right into the chaotic reality of raw data. So take a look at this. It's a little snapshot from a sales data set. Seems simple enough, but the chaos is hiding in plain sight. You've got missing values, see those nans right there? You've got text data, like medium and small, that a model has no idea what to do with. And then you have numbers on completely different scales, from item weight over here to item price way over there. This whole mess basically breaks down into a list of chores you have to do. You've got to deal with the missing values, that's called imputation. You have to turn all that text into numbers, that's encoding, and you've got to get all your numbers onto a similar scale. If you do this manually, every single one of these steps is a place where something can go wrong. And, here's the real kicker. Doing all this once is bad enough. But what about when you get new data? You have to do every single one of those steps again, in the exact same order, with the exact same rules. It's so easy to mess up. It's a recipe for disaster, and it just doesn't scale. So there has to be a better way, right? And of course there is. It's this elegant, automated solution called the scikit-learn pipeline. So what exactly is a pipeline? Well, think of it like this. It's basically a container. It's a single object where you line up all your data processing steps, like filling in missing values, scaling the numbers, and then finally training your model, and it bundles them all together into one neat, tidy package. Really, you can boil any pipeline down to two main stages. First, you've got all your pre-processing steps, the cleaning, the transforming, the scaling, and then, at the very end, you have your final step, which is the actual machine learning model that's going to learn from that perfectly prepared data. My absolute favorite way to think about this is like a factory assembly line for your data. You drop the raw, messy stuff in at one end, it moves down the line, going through each station, imputing, encoding, scaling, and what pops out at the other end is a fully trained model or a clean prediction. It's all one automated process. Now, this all sounds great in theory, but, real-world data is tricky. How does one pipeline handle columns that need totally different kinds of cleaning? I mean, you can't scale a text column, right? To solve this, we need an even more specialized tool. Let me show you exactly what I mean. Your numerical columns, like the price, they need to be scaled. But your categorical columns, like the outlight type, they need to be encoded into numbers. If you accidentally apply the wrong step to the wrong column, you're going to get either an error or just total garbage. We have to be selective. And the magic tool that lets us do this is called the column transformer. It is designed for this one specific job. It lets you create a list of instructions, basically telling scikit-learn, hey, apply this transformer to these columns, and then apply that transformer to those columns. It's incredibly powerful and so well organized. And here's what it looks like. We create this column transformer object, and we just give it a list of instructions. So you can see right here, we're applying a simple imputer, but only to the item weight column. And then we're applying a scalar, but only to the item MRP column. And that little command at the end, remainder equals pass-through, that just tells it to leave every other column alone. So clean, so explicit, I love it. Okay, so we've got our specialized column transformer ready to handle all the different pre-processing jobs. Now we can put all the pieces together into our final, complete machine learning pipeline. This is where the magic really happens. So for our sales example, our final pipeline is going to have three main parts. First, we'll have a custom step to create a few new features. Second, we'll plug in that column transformer preprocessor we just designed. And third, our final model, which in this case is a random forest regressor. And this is the code that brings it all home. We create a pipeline object, and we just give it that list of steps. Each step gets a name and the object that does the work. And that's it.
This one single model pipeline object is our entire workflow. Now all we do is call .fit on this one thing, and it runs everything in order. It's just so clean.
But look, using a pipeline isn't just about writing tidier code. It's a fundamental shift in how you approach machine learning, and it makes your whole process way more professional and robust. This is why it's a total game changer.
So, why does all this matter so much? Well, for that sales dataset, a really deep analysis found that a model built on just the top 7 most important features performed almost as well as a super complex one using all 45. Having a pipeline makes it incredibly easy to experiment with simpler models like this and then actually deploy them reliably. And the real power here is that pipelines unlock this whole suite of professional tools. All of a sudden, complex stuff like cross-validation becomes easy. You can plug your entire pipeline, the whole thing, into Grid Search CV to tune all your settings at once. It's the bridge that takes your project from a messy notebook to a real production-ready system, even connecting with libraries like PyTorch. And really, that's the key takeaway. Working without pipelines, it's kind of like doing a one-off science experiment in your garage. It might work once, but it's fragile and messy. Using a pipeline, on the other hand, transforms your project into a reliable, automated, professional system. So, I'll just leave you with this one question to think about for your own projects. You've built a great model, but is it repeatable? Like, perfectly repeatable? If you got new data tomorrow, could you reproduce your results instantly without a single error? With a pipeline, the answer is always yes.